Okay, welcome everyone. In the last lecture, we have seen what is mobile IP. Then we have seen how packets are delivered in mobile IP. Okay. During the packet delivery, we saw that how home agent forwards the packet to care of address, that is foreign agent, okay, or mobile node, wherever mobile node, wherever it is present, and it is doing all these things via a tunnel. Okay, so let's see what is tunneling and what is encapsulation. Okay, which is important from tunneling point of view. So in this lecture we will see first two types of encapsulation. एक है उसमें IP in IP, and second one is minimal encapsulation. Okay, so let's start with the first part, that is tunneling. So let's start with what is tunneling. Okay, basically tunneling is a very simple concept. Okay, so in the IP packet delivery mechanism, which is used for forwarding packets between home agent and care of address. Okay, whenever we are forwarding the packet between home agent and the care of address. Now care of address can be at foreign agent or it can be at mobile node also. Okay, that we know. Okay, so we know that already. So during this particular packet forwarding, a virtual pipe, okay, which is also known as a tunnel, is established to carry the data packets between HA and COA, that is foreign agent or mobile node. Care of address can be at foreign agent or it can be at mobile node also. Okay, you can see part of example network here on your screen. The same example we have seen initially also in previous lectures. So this particular carrying the tunnel, okay, where packet exchange between the home agent and a foreign agent, that is foreign agent router, via a particular tunnel. So this is nothing but the tunnel. Okay, that is a virtual pipe created between these two. Okay, so it's not physically present. So actually, just a minute, it is not physically present. So it is a virtual pipe. So actually, tunnel is nothing but a link that is established between the home agent and the foreign agent. And assuming that the foreign agent has a COA, so link established between the home agent and the foreign agent is nothing but a tunnel. Okay, but then how it is different from normal link which are established between any two routers? Okay, that we will see. For that, let's see that. So packets entering a tunnel are forward inside the tunnel and leave the tunnel unchanged, that you remember. Okay, so when packets are entering into tunnel, when they come out, they remain unchanged. Okay, because in the fixed network we have seen sometimes packets are fragmented during the transition. Okay, for example, if there is a tunnel between home agent and the foreign agent, suppose. Okay, so that might not be a single link. Okay, there may be some intermediate routers also. Okay, because the packet which is forwarded is carried out through the internet, that we know. So internet may have the routers in between, so between your home agent and the foreign agent. Okay, so in fixed network, if a tunnel is not formed, then packet may be fragmented in between, but in tunneling packets are not fragmented. Okay, so however they are entered, they will be leaving the tunnel endpoint in the same fashion, that is unchanged. Okay, So that is one key difference between normal tunneling in fixed network and the tunneling in mobile IP. Okay, so what is tunneling? So tunneling is simply nothing but sending a packet through tunnel, but this link established between home agent and the foreign agent. Okay, and that is different from normal link which is established in wireless media or wire media, because during this link or during this tunnel packet are encapsulated. Okay, so tunneling is a say in tunneling the packets or so tunneling is a sending packet through a tunnel achieved by using the encapsulation method. Okay, so what is encapsulation? So that is, we will see in latter part what is exactly it is. So tunnel is created by the home agent. So when we are talking about the tunneling, it is always created by the home agent. Okay, so tunnel starting point is at home agent and tunnel end point is at care of address. Okay, which may be a foreign agent or it may be a mobile node also. Okay, that you remember. Okay, so in the case of care of address at the mobile node, tunnel will exit between home agent and the to the mobile node. Okay, so we'll see what is encapsulation. So that is the next question. So because tunnel cannot be formed without encapsulation. Okay, so we'll see encapsulation also. Okay, so encapsulation we have seen previously in the OSI model also, where we have seen that or कि encapsulation क्या होता है. So it is the mechanism of taking a packet consisting of a header and a data, okay, and putting it into a data part of new packet. Means initially, so we know that every packet consists of two parts. Okay, that is, suppose this is a packet. Okay, it consists of two parts. One is the header and other one is the data. Okay, so taking this particular packet consisting of header and data and put it inside a new packet. Okay, that means data part of a new packet. So this process of putting one packet inside the another packet is known as a encapsulation. That means this particular header and data of one packet will become a data for a new packet and new header will be created, and that this particular process is nothing but the encapsulation. Okay, so we have seen this concept in OSI model also in fixed networks. Okay, the reverse operation of this is nothing but taking packet out of the data part of another packet is known as decapsulation. Okay, means again from this particular packet remove the header, again the remaining part data, which will be, if you remove the header from it, again if you go to the data part of it, it will again have the header and data part. So that is nothing but the decapsulation. Okay, both this encapsulation and decapsulation are typically performed when packets are transferred from higher protocol layer to lower protocol layer. Okay, or from lower to higher levels respectively. Okay, so just as I said, we have seen this in computer networks also and or fixed networks also, when we have the different layers like a physical layer, suppose physical layer, data link layer, then network layer, and then transport layer, suppose. Okay, so network layer, we have a packet. Okay, now it is given to the higher layer. Suppose here we have a packet. Okay, so when we give it to the higher layer, we add one more header to it, and this particular become the data part of it. Okay, so this is nothing but the encapsulation. Okay, then it goes to the transport layer, is inserted into the data part of our TCP segment. Okay, so here at network layer also we have header and data. We put it inside the data part of the segment, attach the header that we have seen just now. Okay, again we put this inside of the new header and we send it to the upper layer, session layer. Then again it is the data part of session layer, packet format, and so on. Okay, now the decapsulation means When the transport layer जो रहेगा receives the packet from higher layers, it takes out its own header, gives out only data part to the network layer. So network layer has only a data part, okay, which consists of header and means header for a network layer and the data part of the packet. Okay, so it takes out the header part again and forwards to the data link layer again. Okay, so at the data link layer there will be again header and data part, which is forming a data part of a network layer. Same thing is done. Header part is removed, given to the physical layer. So this particular mechanism we have already seen in the fixed network. Then what is the difference here in fixed network or fixed layer of OSI model and here in IP, mobile IP? So this encapsulation and decapsulation happens between two different layer in OSI model, whereas in mobile IP, these functions are used within the same layer. Okay, so whatever we are doing, that is encapsulation or decapsulation, everything will happen at the network layer only, both encapsulation and decapsulation. Okay, so higher layers are not involved, only network layer is involved here. So that you remember that encapsulation is taken place at network layer only while we are doing the mobile IP communication. Okay, so we will see the mechanism. Okay, let's see the mechanism. Actually, the mechanism is shown in the figure and describe exactly what home agent done at the tunnel entry and what home agent does at the tunnel entry. So as you can see, home agent takes the original packet, okay, which is shown here. See the original packet, which consists of original IP header, okay. Assuming IP is a network layer, that is IP packet and the original data. Okay. Now in this packet, source address will be the correspondent node and destination address will be the mobile node. Okay. So this original packet is put into the data part of the new packet. Put into the data part of the new packet. So this is the new packet. Okay. So I'm denoting it a new packet. Okay. It will have a new IP header now. Okay, in such a way that packet is routed to the COA. Okay, so this header will contain source address of a home agent and destination address of a COA. Okay, so because of this, because this is carried from home agent to the COA. Okay, understood. So this is the resultant package which consists of two header. Okay, the outer header, inner header, and the data. Okay, so this is how the encapsulation is done. Okay, now we'll see the what are the different types of encapsulations are there. Okay, we'll see the types of encapsulation. So encapsulation in mobile IP, specifically we are talking about the mobile IP here, not about the fixed networks now. So it has three types. One is IP in IP encapsulation, that is the first type. Okay. And the second one is the minimal encapsulation. Okay. And third one is the GRE, that is generic routing encapsulation. That is GRE stands for. Okay. So let's see the first type, that is IP packet, that is IP in IP. So this is the most basic type of encapsulation and it is well known and most followed type of encapsulation. Encapsulation of one IP packet into another IP packet as a payload is known as IP in IP encapsulation. Okay. So one IP into another IP means what? Either IP version 4 into IP version 4 or IP version 6 into IP version 4, which is called as the 6-4. Okay. So there are the types of IP in IP encapsulation, or these are the types, two types we have seen. Okay. So as this is the most basic and simplest form of encapsulation, this is mandatory type for mobile IP as specified in RFC 2003. Okay. So if you are going to implement mobile IP, the minimum requirement is you should use or you should be able to implement IP in IP encapsulation at least. Okay. So other types are optional. Okay, that means minimal and JI. So on your screen you can see a packet here. Okay, which is using IP in IP encapsulation. You can see there are two headers. The first one, this is called as an outer header. जो upper part यहाँ पे मैं line खींचता हूँ. Okay. Okay. Outer IP header followed by the inner IP header. Okay, up to this part. Okay, and then below there is a payload. Okay, is the data part. So payload is nothing but your data part. So outer IP followed by the inner IP and followed by the data part. That is the payload. Okay, that is the IP encapsulation. Okay, so let's see the fields of this packet format in IP. So we have studied IP, that is Internet Protocol version 4. So we have studied that in previous in also. So let's revise that and see which fields are changed for IP encapsulation. Okay. Now the first field for the IP data is version field. Here also you can see. Okay. So it is for IP version 4. 4 in the decimal, so in binary it will be 0100. So there are 4 bits, then followed by a field called as a internet header length, that is IHL. It tells you the length of outer header in 32-bit words in IP version 4 packet format. Okay, so IHL represents length of a header. Now in this mobile IP in IP, that means IHL represent length of header of outer part, that is the outer header in 32-bit words. That is the difference. Okay. Then the next field is DS or TOS. Here you can see. When IP was originally invented, is IP version 4 protocol was originally invented. This particular field was called as TOS. Okay. That is type of service. Later on, it was modified and upgraded for different reasons, and sometimes it was called as a DS, that is a differential service. Okay. Now, in latest version, it is known as DSCP. Okay, that is differential service code point. Differential service code point. Okay, what is the type of service? So we send different types of data like audio data, text data, image data, video data. So different types of data required different requirements or push different requirements onto the network. So for example, a text may require minimum bandwidth, so it will not require a large bandwidth because it is having very small size and text is not live data also. That means even if it is delayed by a certain period, we will still receive the information very easily. But video, if you are transmitting video, then it is a time dependent, that is the real time data. So it is dependent on time interval, how quickly the data can be reached towards the destination. Okay, so it requires a higher bandwidth, higher throughput, and lower delay. So different quality of service parameters for different types of data are required here. So TOS field or a type of service, or in this case a DS field, indicates what type of data is included in this particular packet. Okay, so that is what DS about. Now, okay, now why that is important? Because based on this field, routers are chosen for routing. Okay, so if you want a higher bandwidth for your delivery of data, then you will choose a router which provides a better throughput, better bandwidth, and lower delay. Okay, and if you are transmitting a text, then you can go for the cheaper route towards the destination. Cheaper in terms of it will not be providing any large bandwidth. It may not be very costly. Costly in terms of delivery of data in time, so it may be delayed also. Okay, So it will be very cheap in that particular context, so you understand that. So depending on type of service we are choosing routers. That's why this field is important for networks nowadays. Okay, then the next field is the length field. Here also you can see this length is different from IHL. Okay, this length covers the complete encapsulated packet. Means what here, that is in IP version 4, length field indicates length of total packets. So IHL represent length of a total header. Okay. Now length field indicates length of a total packet. So in this case, total packet is a total encapsulated packet. Okay. For outer header, length indicates the length in total encapsulated packet. Okay. Then the next three fields are similar to IP version 4 functioning. So they are used. So they have no different meaning in IP. Like IP identification, it is used for identifying the sequence number. So it is important from a receiver point of view whenever they are receiving packet in correct order or not. For that, it can be useful. So sequence number is present in TCP, not in IP, but it works similar to that way. Then there are flags. Okay, flags indicates here whether this packet is fragmented or not. So there are three flags, that is 0, then D, then M. ऐसे तीन रहे थे. D means don't fragment, M is more fragment. So if M is 1, so this packet is fragmented. D is 1, that is, or that means this packet should not be fragment. So fragment offset, the packet is fragmented. Okay, the offset from the original packet is mentioned in the fragment offset. Okay, the next field is the TTL field. Now TTL denotes, that is the TTL stand for time to live. It denotes times in seconds, so within which packet must be delivered. So this is important in order to avoid looping in the network. So if TTL is infinity, packet will keep on circulating between the network. So to avoid this, the TTL is mentioned. So now in IP version 4, TTL should be kept high enough so that packet will reach at least to the COA. Okay, so it doesn't matter if there is a multiple routers in between home agent and the foreign agent. So if home agent and the foreign agent has multiple routers in between them, the TTL will be always equal to 1. So all routers in between will be called as a single hop. Okay, so this is to make sure, or this is important from this point of view, that your mobile node is just a one hop away from the home network. Okay, so it appears as it is. So it appears as if you are connected to the home network. So that is called as a TTL field. That is very important. So this tunneling is kept hidden from the other part of the network. Then the next will denotes the layer 4 protocol. Okay. In this case, for outer header layer, layer 4 protocol includes a code for IP in IP encapsulation. So it denotes the type of protocol used inside the payload part. So the payload part of the outer header is this part. So this is the payload of a outer header. So what is the payload part? It is the IP version 4 packet again. So that's why here it is mentioned as IP in IP. Then there is a IP checksum also. Okay. So IP, when we are talking about the IP checksum, this is used for detection of errors. So checksum is calculated for header part to detect if there are any errors at the receiver. It will be calculated again and match with the original, and then it will be decided whether the packet was contaminated or not. Then the next two fields are source address and the destination address. Okay, as you can see, source address, as this is the outer header. जब तक रहेगा outer header, if I am talking about the outer header which is created by the home agent, in this case source address will be the IP address of HA and destination address is the care of address or foreign agent or COA. Okay, so destination address will be care of address. If there are no options, outer header is finished. Okay, now next inner header. Okay, so we'll see what is the content of inner header also. Okay, so in inner header, if you observe in inner header, that carries similar fields to the outer header with slight difference. Inner header remains almost unchanged during the encapsulation, just showing the original CN and MN as the source and destination address. Okay, that you understand. Now, inner header is actually a packet sent from a correspondent node. So, correspondent node, if it is sending the packet, its source address will be CN's address and destination address will be address of mobile node. Okay, so COA is not mentioned in the inner header, so that is the inner header which carries almost every field similar to the outer header. The change is in the TTL and layer 4 protocol. Okay, so now length field will be also length of entire packet for only the inner part. Okay, the TTL field which is decremented by 1, TTL field which is decremented by 1. So this means, as I said, in this case, TTL is only equal to 1. In outer case, it may be higher enough to reach a care of address. So you can keeping it as a 2 or 3 or 4 for outer header. So TTL can be 2, 3, 4, anything for outer header. But for inner header, TTL should be always equal to 1 to indicate that mobile node is just a one hop away from the home agent. Okay, so this is a very important feature of tunneling, as it allows mobile nodes to behave as a it is attached to the home network even if it is in the foreign network. Okay, so no matter how many real hops packet has to take in the tunnel, as I said, between the home agent to the foreign agent. So there may be multiple hops due to different routers present in the network or in the internet. So there may be multiple hops, but TTL will remain one, as I said previously also, to hide the tunneling part from the rest of the network. Okay, and to make mobile node feel as if so it is still connected to the home network. Okay, so these are the changes the layer 4 protocol is having. So it will be including type of protocol included in the payload part. So since this is at the network layer, the next layer will be the transport layer. So type of protocol will be TCP. Okay, in this case, because TCP or UDP, that will be the type of protocol, because payload part contains TCP segment or UDP segment. Okay, so whichever is there. So after the that checksum, as usual, calculated for inner header, source address and the destination address are calculated. If there are no options followed by the actual data. Okay, so finally payload follows the two header. So this is regarding IP in IP encapsulation, which is a basic part of mobile IP. Now, if you observe, there are so many fields that are repeated, like version, then IHL, okay, DSTOS, fragment offset, flags, okay, IP identification. These are fields that are repeated. Okay, so why we are sending repetitive information here? So that is the another question. So we are wasting our bandwidth because size of packet will increase because of this repetitive information. So in term of one packet, that not maybe substantial, but size of packet increases considerably. If there are so many packets available in the network which are going through the tunnel, so it is consuming too much bandwidth. Okay, so that's why the next encapsulation technique is developed. Okay, that is minimal encapsulation. The new technique is minimal encapsulation. Now, minimal encapsulation avoids the repetition of identical fields like IHL, okay, TTL, version, DS, and so on. Okay, so similar to IP and IP, outer header is same as that of in IP in IP. Only thing that is changed here is layer 4 protocol. So here the code will be 55 to indicate of minimal encapsulation. That is minimal encapsulation packet is inside the data part. Okay, so apart from that, all other fields are same. Only layer 4 protocol field is modified to indicate the minimal encapsulation. So in the data part of outer packet, so we have minimal encapsulation packet. So what is that? Let's see that this type of encapsulation is only applicable for non fragmented packet. So if your packet is fragmented into different small packets, then the minimal minimal encapsulation will not work for that. Okay, that you remember. Okay. So if your packet is fragmented into different small packets, the minimal will not work for that. Okay. So if you see the inner part of the packet, it is in the outer header plus data and several fields are removed. Okay, the first field is the layer 4 protocol, which is indicating which type of protocol is present. Okay, or which type of packet is present inside the payload. As usual, it is a TCP or UDP, just like in the IP and IP encapsulation. So next bit is, just a minute. Okay, can you able to see the diagram on screen? Anyone just
Yes, sir. Yes.
now see this particular diagram? That diagram was wrong on the this thing in PPT. Okay, so here you can see how it is changed now. This particular part I am talking about. Just okay, okay. Now see here, this particular gray part is only changed. That is the inner header is changed now. So I'm talking about that. The first ऊपर वाला वर्जन वगैरह अब जस्ट समझो. So नीचे जो लिखा है that is protocol is the version 4 protocol. Okay, then here the S is equal to 1, that the original sender IP address is mentioned in the header, otherwise it is not mentioned. If S is equal to 0, then original sender IP address is not mentioned, but this happens rarely. So next few bits are reserved. Okay, after that IP checksum will be there. Okay, so which is same to the previous technique, calculating checksum of a header part in the minimal encapsulation packet. So first is the destination address, because that is mandatory. So destination address is the IP address of mobile node, similar to IP in IP. And after the destination address, okay, the next field is the source address. Okay, now if you compare this with the IP in IP encapsulation, these fields are changing their positions. In IP in IP, source address was first, and then there was a destination address. In minimal encapsulation, this is the only difference. Okay, here what is that? In minimal encapsulation, destination address is first, then there is a source address. Okay, that is the change. Why? Because in minimal encapsulation, source address is optional. If S is 0, source address will not be present, and if there are no options, directly payload will be start after the destination address. Okay, but S is equal to 1. If S is equal to 1, one source address will be present, and that's why it is included after the destination address here. Okay, इसलिए यहाँ पे if s equal to 1 लिखा है, देखो, that is optional. Okay, that you understand. And after that payload starts, उसके बाद में payload starts होगा. Okay, as you can see, there is no room for fragmentation. Okay, नीचे कुछ भी नहीं है. So this is not the same packet which was sent by the correspondent node. It has been modified in its header part, not the data part. Data is kept as it is. So header is changed. Repeated fields are removed now. So new header is created called as a minimal encapsulation header. Okay, and it is inserted into the outer header. ऊपर वाला part है outer header. Outer header is kept as it is. Okay, only inner header is changed now. Inner header में ये सब ऊपर वाले ये जो दो lines दिख रहे हैं आपको, these two lines are removed now. 3 lines are removed, and instead of that, only this particular single line is kept now. IP checksum is there, but rest bits are changed now. Okay, it is called as a minimum encapsulation. Okay, so this is about minimal encapsulation. Okay, so we have seen two encapsulation type in today's lecture. One is IP in IP encapsulation, and second one is the minimal encapsulation. Okay,